A snake is a type of reptile that is long, limbless, and highly specialized in the way it moves and behaves. It is known for its elongated body, which allows it to glide smoothly over the ground or through tight spaces. The structure of a snake is different from any other animals because of the lack of limbs and the presence of an extended backbone made up of many vertebrae. This design helps it remain flexible and silent in movement. The movement of a snake is controlled by a series of muscles that work in coordination with its ribs and spine. This system allows the snake to push against the ground in a wave-like motion, enabling it to move forward with remarkable precision. A snake can navigate across uneven surfaces, climb trees, or even swim, all without the need for legs or external limbs. A snake has a highly developed sense of perception. It uses its tongue to gather information from its surroundings by flicking it in and out of its mouth. The tongue collects scent particles from the air and delivers them to a special organ that processes these chemical signals. This allows a snake to detect the presence of other animals or changes in the environment without relying solely on vision or hearing. Though snakes do have eyes, their vision varies depending on the individual and the time of day. Some are more attuned to daylight, while others function better in dim conditions. Rather than relying only on sight, a snake interprets vibration, scent, and temperature to form a full understanding of its surroundings. It has adapted to sense warmth, which helps it locate nearby animals. The jaw of a snake is uniquely structured, allowing it to open its mouth far wider than most other animals. This trait enables it to consume prey that appears much larger than its head. The bones of the jaw are not fused together in the same way as in other mammals or reptiles, which gives the snake a high degree of flexibility in consuming its food whole. Despite their silent approach, snakes can communicate with the world around them through body posture and motion. Some may coil tightly, raise parts of their body, or vibrate their tails when they feel threatened. These gestures serve as warnings or defensive behaviors meant to deter predators or threats without the need for sound. Snakes are cold-blooded animals, which means their internal temperature changes with the external environment to regulate their body temperature. They often seek warmth when it's cold and shade when it's hot. Their metabolism slows down when temperatures drop, making them less active and more dependent on conserving energy. Reproduction among snakes is a specialized process. While the details may differ between individuals, the general approach involves internal fertilization and a period of development. Some snakes lay eggs, while others give birth to live young. Regardless of method, the young are usually independent soon after birth, with the instincts needed to survive. Many snakes rely on stealth and patience, rather than chasing or overpowering their prey with speed. They often remain still for long periods, waiting for the right moment. When the opportunity presents itself, the snake strikes with accuracy. This patient approach is part of what makes snakes effective hunters. The body of a snake is covered in a protective outer layer that is periodically shed. Shedding is a natural part of the growth process and also helps the snake get rid of any external parasites or damaged skin. During this time, a snake may become less active or seek out quiet areas where it can complete the process without interruption. Snakes play an important role maintaining balance in ecosystems. They act as both predator and prey, helping to control populations of smaller animals while also serving as a food source for larger ones. This dual role places them in a key position within natural systems, contributing to the overall stability of the environment. Some people view snakes with fear or superstition, but others respect them for their strength, efficiency, and adaptability. Their image varies widely across cultures, often symbolizing both danger and wisdom. Despite common fears, most snakes prefer to avoid confrontation and rely on defense mechanisms rather than aggression. The hearing of a snake is different from that of other animals. It does not hear airborne sounds well, but can detect vibrations through the ground. This form of vibration sensing gives the snake information about movement around it. As a result, it can detect the approach of animals or people without visual contact. The design of the snake's body supports a quiet, stealthy lifestyle. It moves with little sound and leaves minimal disturbance, making it difficult to detect. This stealth is an advantage in both hunting and avoiding threats. Its ability to blend into surroundings also enhances its chances of survival. The internal organs of a snake are arranged in a linear fashion to fit within its narrow body. It has one lung that is more developed than the other, a stretched digestive system, and a heart position to support its shape. This internal structure supports the unique demands of its lifestyle. Snakes continue to adapt to a wide variety of conditions. They exhibit a level of resilience and flexibility that has allowed them to persist over long periods of time. From the way they move to the way they interact with their environment, snakes demonstrate a specialized approach to survival. Though misunderstood by many, the snake remains one of the most efficient animals in nature. Its movements, hunting techniques, and survival instincts reflect a high level of refinement. It is an animal that relies on precision, silence, and adaptation to thrive in the world around it. The snake stands out among reptiles for its simplicity of form and complexity of function. Its appearance may seem basic, but the animal is equipped with a wide range of skills and responses that make it highly effective. Through its quiet presence and sharp instincts, the snake occupies a unique place in the animal kingdom. Snake's scaly skin is a unique type of integument that serves as the outer covering of a snake's body. Composed primarily of keratin, the same protein found in human nails and hair. This keratinized skin is arranged in overlapping scales, which provide a flexible yet protective armor that allows the snake to move efficiently while safeguarding its internal systems. The scaly texture of snake skin plays a vital role in minimizing water loss through evaporation, especially important for reptiles that cannot regulate their internal temperature like mammals. These scales help the skin retain moisture, making the animal more resilient to various environmental conditions. Each scale on a snake's body is formed from the epidermis and grows in a specific pattern, depending on its location. These patterns are functional rather than purely decorative, often aiding in movement, camouflage, or other physical functions. The scales are not all the same shape. Some are broad and flat, while others are narrow or keeled. Scales assist snakes in locomotion by creating friction against surfaces. As the snake contracts and relaxes its muscles in a wave-like motion, the rear edges of the scales grip the surface, allowing the body to be pushed forward. This adaptation is crucial since snakes lack limbs and rely entirely on muscular movement and skin interaction to travel. The outer layer of a snake's skin is not permanent and is shed periodically in a process called ecdysis. This shedding helps remove parasites, renews worn-out skin, and allows for growth. During this process, the snake's body secretes fluid between the old and new layers, loosening the outer skin so it can be peeled away in a single piece. The shedding of the scaly skin is an essential part of the snake's biology and can occur several times a year, depending on age and health. Younger reptiles tend to shed more frequently as their bodies grow rapidly, while older individuals may shed less often. This process requires the animal to be in a calm and secure environment to ensure successful molting. Snake scales also play a role in protection against predators. The tough keratinized skin resists minor abrasions, bites, and other physical trauma. The colors and patterns on the scales can help break up the outline of the animal, making it less visible to threats. Scaly skin contributes to thermal regulation indirectly by affecting how heat is absorbed or reflected. The texture and pigmentation of the scales can influence how much sunlight is absorbed or deflected, helping the animal manage its body temperature in the absence of internal heat regulation. In addition to protection and movement, the scales serve a sensory function in some cases. Although not all scales have this property, some contain nerve endings that help the animal detect vibrations or changes in the environment. This allows for heightened awareness without relying solely on vision or hearing. The texture of snake skin varies greatly depending on the part of the body. The ventral scales, located on the underside, are typically broader and more elongated than the dorsal ones. These ventral scales are crucial in gripping the ground and providing traction during movement. Over time, scaly skin has evolved to suit a wide range of ecological roles. While we are not discussing habitats, it's worth noting that this adaptability is one reason snakes are found in such varied environments. The skin structure supports survival in numerous conditions without requiring major changes in the internal anatomy. Despite its durability, snake skin is still susceptible to injury and disease. However, the ability to shed allows minor damage to be corrected during the renewal process. This natural maintenance helps keep the animal healthy without requiring external grooming or attention. Unlike mammals, the skin of a snake does not have sweat glands or fur. This makes it smoother and less porous. The scales, therefore, act as both armor and insulation, albeit in a very different way compared to hairy or furry animals. Snake skin coloration is determined by the arrangement of pigments in specialized cells beneath the scales. These colors can change slightly as the animal grows or as old skin is replaced, but they generally remain consistent, allowing for identification based on pattern. The smoothness or roughness of the skin can also vary. Some snakes have highly polished, glossy scales that reflect light, while others may have rough or ridged scales that diffuse light. These differences may influence how they interact with their environment and other animals. Scales can also be a means of species identification among researchers due to their number, shape, and arrangement. However, from a functional perspective, what matters most is how these scales enable the snake to survive, hunt, and avoid threats in a world without limbs or claws. The development of scaly skin begins even before hatching, where the skin is already forming its initial layers in the embryo. The structure becomes more complex as the animal matures, but the fundamental composition remains consistent throughout its life. Ultimately, the scaly skin of a snake is a multifunctional adaptation that enables movement, defense, hydration control, and sensory input. The lifespan of a snake can vary greatly depending on numerous factors, including size, genetics, environment, and whether it lives in captivity or in the wild. On average, snakes tend to live anywhere from several years to multiple decades, with some reaching over 20 or even 30 years under the right conditions. However, this longevity is not guaranteed for every individual, as natural threats and health issues can significantly reduce lifespan. In the wild, snakes face numerous challenges that can limit how long they live. Predators, disease, injury, and inconsistent food supply all play a role in shortening life expectancy. Many young snakes do not survive past their first year due to predation or environmental hazards. Only a fraction of hatchlings reach adulthood, and even fewer reach old age in their natural setting. When a snake is kept in captivity under proper care, its chances of living longer increase substantially. Without the dangers found in nature, and with consistent access to food, clean water, and medical care, captive snakes tend to outlive their wild counterparts. Many reptiles kept by humans can thrive for decades if their needs are properly met. A snake's size often correlates loosely with its lifespan, with larger snakes tending to live longer than smaller ones. However, this is not a strict rule and exceptions exist. Larger snakes may take longer to mature, but may benefit from slower metabolic rates and longer life cycles. Smaller snakes, while quicker to mature, may experience a faster aging process. The biological processes that control aging in snakes are still not completely understood, but like many reptiles, they exhibit relatively slow metabolic rates, which contributes to their longevity. A slow metabolism can reduce the wear and tear on internal organs, resulting in a more gradual aging process compared to warm-blooded animals. Reproduction can also affect lifespan in snakes. The energy cost of producing offspring, especially infrequent or large clutches, may tax the animal's body and potentially shorten its life over time. This is especially true in environments where resources are limited and recovery from reproduction is slower. Some snakes may live only a few years due to environmental stress, disease, or injury, while others may live more than 20 years if kept healthy. The broad range of lifespans across different individuals and populations highlights how adaptable these animals are. Despite their vulnerability to external factors, even in captivity, a snake's lifespan is not guaranteed. Improper care, such as incorrect temperature, humidity, or diet, can lead to chronic health problems that reduce longevity. Snakes are sensitive animals, and small mistakes in husbandry can accumulate and affect their overall well-being. Veterinary care can play an essential role in extending the life of a captive snake. Regular health checks, early detection of diseases, and treatment of parasites all contribute to a healthier and potentially longer life. However, access to proper care is not always available or prioritized. In general, a healthy snake with proper care has the potential to live a relatively long life compared to many other animals of similar size. Their resilience and biological design support longevity when conditions are favorable. However, they still remain vulnerable to age-related decline, including decreased activity, digestion issues, and reduced reproductive performance. Aging in snakes is often subtle. Unlike mammals, they do not show obvious signs of aging such as graying fur or cognitive decline. Instead, the signs are often observed in reduced feeding frequency, slower movement, and more frequent health complications. These signs, while gradual, are natural indicators of the aging process. Because snakes continue to grow slowly throughout much of their lives, growth rate is not always a reliable indicator of age. Size alone can be misleading, especially when diet and temperature influence growth more than chronological age. Accurate age estimates often rely on records or observations rather than physical traits alone. In captivity, documented lifespans provide a more accurate picture of how long snakes can live under ideal circumstances. These records help scientists and keepers understand what conditions support longevity and what factors can cut life short. Over time, data has shown that controlled environments can add many years to a snake's life. Longevity in reptiles like snakes has fascinated researchers for decades. Their ability to live long lives with slow metabolisms and efficient biological systems sets them apart from any other animals. This has led to ongoing studies about how reptiles age and how their lifespans can be improved both in the wild and in captivity. In nature, even long-lived snakes rarely reach their full potential lifespan due to the challenges of survival. Predation, disease, and injury are constant threats that limit the number of snakes that reach an advanced age. Survival to old age is a rare achievement in wild populations and often depends on a combination of luck, skill, and favorable conditions. Understanding the factors that affect snake lifespan is essential not only for conservation efforts, but also for those who care for these animals in captivity. Lifespan is shaped by more than just genetics. It reflects the total quality of life, including diet, environment, healthcare, and stress levels. Ultimately, the lifespan of a snake is highly variable and influenced by a complex mix of biology and external factors. While some may live only a short time, others can reach impressive ages under the right conditions. Regardless of the duration, each snake's life reflects a unique balance between its internal resilience and the world around it.